Bismillahirrahmanirrahim. Allahumma rabbi zidni ilma. Dear students, our today's lecture topic is Transmission Control Protocol. As we have discussed about TCP in our previous lecture also, but in that lecture we would not be able to complete Transmission Control Protocols topic. In today's lecture we will complete Transmission Control Protocols topic. TCP is basically used for reliable data transmission. It supports error control as well as it supports flow control. So transmission control protocol is used for reliable data transmission. There is a process of three-way handshake in which first of all connection will be established, then data will be transferred, and after that connection will be disconnected. Flow control. TCP uses sliding window to handle flow control. Dear students, sliding window flow control is a mechanism in which we can transmit data in the form of frames, but at the same time more than one frames can be transmitted. Next point, the size of the window is determined by the lesser of two values, RWND or CWND. When the data is transmitted in the form of frames, we can set the window size, and according to that size at the same time more than one frames can be transmitted. Let's suppose if the window size is 7, at the same time 7 frames can be transmitted simultaneously. So next point, RWND. It is the number of bytes the receiver can accept before its buffer overflows, because every device which is receiving device have limited buffer capacity, and if there is no flow control the buffer will be overflow and the data will be lost. Next point, CWND. It's the value determined by the network to avoid congestion. In the previous lectures we have discussed about congestion. Congestion is basically network overflow. When the network is overflowed, we can say the network is congested. So we should control this problem or this issue. Last point, the receiver controls most of the aspects. Normally, flow control or congestion control is deployed on receiving side or destination side. Error control. Dear students, as you know that when the data is transmitted from source to destination, let's suppose data was 10 and the receiver receives the data in the form of 01, so the bits have been changed. These are errors, or this is an error. So it includes mechanism for detecting corrupted segments, lost segments, out of order segments, and duplicated segments. Let's discuss all these segments one by one. Number one is corrupted segment. As just I have told that if the data has changed, let's suppose 1 is changed into 0 and 0 into 1, so these are corrupted bits, and likewise if there are many bits and all those bits or those bytes or those segments have been changed like this, so these are called corrupted segments. What is lost segment? Lost segment means data is not received by the receiver, so in this case data will not receive. Next is out of order segment. It means if we have transmitted 5 bytes, byte 1, byte 2, byte 3, byte 4 and byte 5, but the data is received by the receiver in this sequence. First byte 5 received, then byte 3, then byte 2, then byte 4, then byte 1. So this is not in order data receiving. So this is out of order segments. Next is duplicated segment. What does it mean? It means that receiver has received a specific segment and sender will not receive the positive acknowledgement. Sender will retransmit a specific segment and the receiver have now duplicated segments. So these are problems or these are issues all these issues must be controlled. All these issues must be controlled by the receiver. Second point, achieved through the use of three simple tools. How we can control errors: checksum is used, acknowledgement is used, and retransmission is used. So we have discussed about these techniques in our previous lectures. Dear students, as I have told in the previous slide that we have discussed about checksum, acknowledgement and retransmission technique in our previous lectures, but we'll go through over here also. What is checksum? Each segment includes a checksum field used to check for corrupted segment. TCP uses a 16-bit checksum. Corrupted segment is discarded by the destination and is considered as lost segment. When we have discussed about TCP header, there was a field of checksum. So in checksum field, we will set the value and different mathematical calculation is used to detect errors. And in this way, errors can be detected and the receiver will discard the specific segment. Acknowledgement. Dear students, acknowledgement is like a green signal from destination to source. When the source device will transmit data towards destination, destination after receiving proper data segments will send a green signal which is called acknowledgement and which is basically positive acknowledgement. And when the acknowledgement is received by the source will transmit next data segment or next different data bytes. So confirms the receipt of data segments. Next point, to control segments that carry no data but consumes a sequence number are also acknowledged. Acknowledged segments are never acknowledged. As just I have discussed that data is acknowledged always, but when the acknowledgement is received by the source, this is acknowledged, but there will not be any specific sequence number which is allocated. So after receiving the acknowledgement, sender will send next data segments. Retransmission. A segment is retransmitted on two occasions when a transmission timer expires. Dear students, when the sender will send segment towards receiver, receiver must send a positive acknowledgement within a specific time towards sender. If the sender will not receive positive acknowledgement in that specific time, then the sender will retransmit the specific segment again. Next point, when the sender receives three duplicate acknowledgement, if the sender will receive many acknowledgement from the receiver side, then there will be confusion. So the sender will retransmit the segment again. Second main point, retransmission after RTO. RTO is retransmission timer out. TCP maintains one RTO timer for all outstanding sent but not acknowledged segment. Sender will keep the record of all those segments which has been sent but the acknowledgement is not received yet. Second point, when the timer matures, the earliest outstanding segment is retransmitted in a specific time which is set. When the time has expired, all the outstanding frames will be retransmitted because all these frames acknowledgement has not received from the receiver. Value of RTO is dynamic and is updated based on RTT. This is round trip time which we have discussed in our previous lectures. What is RTT? Our request maintains a specific time on sender to receiver link. That specific time is called RTT or round trip time. Fast retransmission. Let the value of RTO, retransmission timer out, be very large. If the value of RTO is set in a very large manner, then there will be a problem which we will discuss in our next 2 points. Point number next, One segment is lost and receiver receives so many out of order segments that they cannot be saved buffer size. Let's suppose if sender has sent 5 segment 1, 2, 3, 4 and 5, segment number 2 was lost and the other segments receive out of order. Let's suppose segment number 5 was received and after that segment number 3, after that segment number 4 and so on. So this is a problem which is out of order receiving data. Next point, when the sender receives 4 acknowledgement with same value, 1 original and 3 duplicates, even though the timer has not matured, the fast retransmission requires that the segment be resent immediately. Now in this case, sender has received 4 positive acknowledgement for same specific frame and sender will retransmit. This is called fast retransmission, but the transmission or retransmission will be for specific frame or specific segment. Adaptive retransmission. TCP attempts to determine the approximate round-trip time between the devices and adjusts it over time to compensate for increases or decreases in the average delay. Dear students, round-trip time is used on network to process a specific request for client. When client sends a request to server, specific time is used to process that request, that is called RTT or round trip time. Second point, TCP aims for an average round trip time value for the connection. Average round trip time means if the request is sent 4 times and the time varies to process this request, all that time is calculated in the average manner. This is average round trip time. Next point, this average should respond to consistent movement up to down in the round trip time without overacting to a few very slow or fast acknowledgements. Acknowledgement may be slow or fast, but a round trip time will be calculated in again average manner. Last point, TCP re-estimates round trip time after every successful transmission, not retransmission. So RTT is used for successful retransmission. If there is unsuccessful retransmission, then that time is not calculated and RTT is based on successful retransmission. Congestion control. Dear students, अपनी लाइफ में भी हम ये वर्ड यूज़ करते हैं, कंजेस्टेड का हम वर्ड यूज़ करते हैं. जो हमारी लोकेलिटीज़ होती हैं जहां हम रहते हैं, अगर वो एरिया कंजेस्टेड हो जाए तो उसके लिए हम ये वर्ड यूज़ करते हैं कंजेस्टेड का. और इसी तरह से कंजेशन का वर्ड हम नेटवर्क में यूज़ करते हैं. फर्स्ट ऑफ ऑल वी विल सी द डेफिनेशन ऑफ कंजेशन. Network congestion is basically data networking and queuing theory is the reduced quality of service that occurs when a network node or link is carrying more data than it can handle. जितना डाटा वो हैंडल कर सकती है नोड या वो लिंक, अगर उससे ज़्यादा डाटा ट्रांसमिशन स्टार्ट हो जाएगी, उसको हम बेसिकली कंजेशन कहते हैं. और इस कंजेशन को कंट्रोल करना चाहिए, इसको रोकना चाहिए, इसको इस पर ओवरकम करना चाहिए. सो इन डेफिनेशन ओवर स्लाइड, TCP's general policy for handling congestion is based on 3 phases. First of all is slow start, which is exponential increase. Next is congestion avoidance, which is additive increase. And the last one is congestion detection, which is multiplicative decrease. So first of all, what is slow start? Basically, over here, TCP slow start is one of the first steps in the congestion control phases. It balances the amount of data a sender can transmit with the amount of data the receiver can accept. So over here, basically sender and receivers receiving capacity and sender transmitting capacity must be balanced. So this technique is used over here. Second is congestion avoidance, which is additive increase. The policy of additive increase may, for instance, increase the congestion window by a fixed amount every round trip time. When congestion is detected, the transmitter decreases the transmission rate by the multiplicative factors. So over here, when there will be congestion, transmission speed by the transmitter will be slowed down. And the last one is multiplicative decrease. Over here, different algorithms are used, and one algorithm which is used over here is on feedback control from receiver side. So receiver send feedback towards transmitter about congestion, and that congestion will be controlled on that specific algorithm based. Congestion detection. First point, if congestion occurs, the congestion window size must be decreased. So in the previous slide, we have also discussed that there is a window size about congestion, which is congestion window size, and window size concept we have also studied in sliding window flow control, which is used to send more than one frames at the same time. So over here, the congestion window size must be decreased to control the congestion. Second point, sender can guess congestion by need to retransmit a segment. If congestion occurs, then definitely specific segment will be discarded or specific segment will be lost due to congestion, and after specific time that segment must be retransmitted by the sender. So in this way we can control congestion. The last point, retransmission can occur in one of the two cases. First is timeout, as we have discussed in our previous slides. Then specific data will be transmitted by transmitter, and there will be a specific time to receive acknowledgement from receiver. In that specific time, if the acknowledgement is not received, then sender will retransmit the frame or segment which is transmitted by the sender already. Second, acknowledgement received and multiple acknowledgements, and we have discussed if 3 acknowledgements are received from receiver, the sender will confused and it will retransmit that specific frame. So in this way, congestion will be detection. Congestion detection. So dear students, over here there is more detailed discussion about previous slide. So there are 2 points, if detection is by timeout, and the second main point, if detection is by 3 acknowledgements. So first of all, we will discuss about timeout. Point number 1, it sets the value of the threshold to 1/2 of the current window size. There are 2 concepts over here. First one is threshold and second one is window size. If the total window size is 8, threshold will be 4. So what is threshold? Threshold is basically the value which is set by transmitter. Second point, it sets CWND to the size of one segment. We have discussed about CWND, which was window size, and this is about one segment. And the last point, it starts the slow start phase again. About slow start we have discussed in our previous slide. If there is congestion, the sender will start to data sending at slow pace. So in this way we can detect congestion. Second main point, if detection is by 3 acknowledgement, It sets the value of the threshold to 1/2 of the current window size. Again, this is same point. It sets CWND to the value of threshold. It starts the congestion avoidance phase. So over here, congestion avoidance phase is started. So congestion avoidance phase mean when congestion will be detected. Now how we can control that congestion? So we can slow down the data transmission speed. In this way we can control congestion. So there is main one method or mechanism to control the congestion, which is to slow down the data transmission speed. Congestion example. Dear students, this is our last slide of today's topic. Over here a graphical representation is shown. Congestion window size and time is shown at y and x-axis. You can see the time, which is slow start, then congestion avoidance, and then congestion avoidance. Slow start, congestion avoidance, we have discussed about these techniques which are used for congestion control mechanism, and there are spikes for loss detected by timeout. And when the congestion will be detected, transmission speed will be slowed down. So data transmission speed will be slowed down, and in this way we can control congestion. So dear students, after delivering lecture in a class, the teacher say to ask the questions, but as you know that now we are in different online education system, so this is not like possible to ask the question in that manner, but you are always welcome to ask the questions, to post your questions, to post your queries using your Google Classrooms. So try to read your lectures carefully and post your questions so that you may be able to learn all the lectures in a very good way. So dear students, thank you very much for your concentration, for your learning, for your passion. I hope best of luck for all of you always.